Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound shown is 2-benzylidene-cyclopentane, 1-1, a cyclopentane with a benzylidene substituent at C to making an exocyclic C is equal to C conjugated with the ring carbonyl. The molecule has an exocyclic alkene, C is equal to C between ring C2 and the benzylic carbon, and a ring endocyclic C is equal to C, the enone double bond within the 5-membered ring. Actually, re-examining, the structure is a cyclopent 2N1-1 where C2 bears a benzylidene group, i.e., the ring double bond is between C2 and C3, and there is also a C is equal to C exocyclic at C2 connecting to phenyl. More precisely, the compound is Ez2-benzylidene-cyclopentane 1-1, a 5-membered ring ketone with an exocyclic double bond at C2 bearing a phenyl group. Moving on to the next step. 1 mole of H2 at 2 to 3 atm with 10% PDC, heterogeneous hydrogenation. 1 mole of H2 reduces 1 degree of unsaturation. The exocyclic C is equal to C, benzylidene double bond, is more reactive toward catalytic hydrogenation than the isolated enone system under mild conditions, so 1 mole H2 selectively reduces the exocyclic alkene. Moving on to the next step. Reduction of the exocyclic C is equal to C, CH is equal to pH, CH2 pH gives 2-benzylcyclopentane 1-1. In this product, C2 of the cyclopentanone ring becomes a new stereocenter, it bears H, benzyl group, and is part of the ring with the adjacent carbonyl. The carbonyl carbon, C1, is not a stereocenter. C2 is the only stereocenter generated. And for the final step, catalytic hydrogenation on a heterogeneous PDC surface delivers H2 from one phase, SYN addition, but since the substrate, 2-benzylidene-cyclopentane 1-1, is planar achiral at the reacting center, the two faces of the exocyclic double bond are enantiotopic. Adsorption can occur from either phase with equal probability, generating the R and S configurations at C2 in equal amounts. The product 2-benzylcyclopentane 1-1 has one stereocenter, C2. Since both enantiomers are formed in equal amounts, the two faces are equally accessible on the achiral catalyst surface with an achiral substrate. The product is a racemic mixture, equal amounts of R and S enantiomers. A racemic mixture is optically inactive due to external compensation. A. Diastereomers. Diastereomers require at least 2 stereocenters. The product has only one stereocenter, so diastereomers cannot form. C. Meso. A meso compound requires at least 2 stereocenters with an internal plane of symmetry, not applicable here. D. Optically pure enantiomer. This would require asymmetric induction, chiral catalyst or chiral substrate, which is absent here. Therefore, the correct answer is B. Therefore, the correct answer is option B.